Okay, in the last video we solved equations that look like logarithm equals logarithm. Now we're going to look at equations that look like logarithm equals number, or even logarithm equals an expression. What we're going to do is the same thing we're always going to do with logarithms. The opposite of a logarithm is an exponential, so we're going to use an exponential to hopefully cancel out this logarithm. That should be kind of your take-home message from this whole section, is we use exponents to cancel out logs and vice versa. So this right now is log, which is the common logarithm, meaning the base is 10. So if I want to cancel it out, I use an exponential where the base is 10. And unlike the previous video where we had some shortcuts, we're not going to really have a shortcut for this one. If we have log equals a number, we're going to have to use the exponent on both sides. Okay, so an exponent with a log should cancel each other out, and we have x minus 5 is equal to 10 to the 4th. Maybe type that in a calculator. Maybe we already know what that number is. It's a 1 with 4 zeros. And so our last step is solve the equation, which would be x is subtracted by 5, so we're going to need to add 5 to both sides. And so our answer, x is 10,005. And as I mentioned in the previous video, you should probably double check your answer. If we take log of 10,005 minus 5, we should end up with 4. So let me just pull the calculator out real quick. Log, and that's an log log, and then 10,005, so 10005 minus 5, close parentheses, should be 4. Yep, looks good. Okay, let's try one more. Let's try and solve log base 2 of x plus log base 2 of x plus 2 is equal to 3. Okay, this is slightly more complicated. Again, our general strategy is if we see a log plus a log, or if we see multiple logs on one side, we first want to combine them. So our first step is always going to be combining logs, and our rule for log plus log is multiply the insides. So log base 2, keep the same base, and multiply the inside. So x times x plus 2. Okay, it's slightly more complicated than the last one, but still the same idea. We have a log of something equals a number, and so we're going to use an exponential to get rid of the log. And the log has base 2, which means we should be using an exponential with base 2. So 2 to the power left-hand side should be equal to 2 to the power right-hand side. And this is something we have to be really careful of, because it's really easy to get these two confused. Is it supposed to be 2 cubed or is it supposed to be 3 squared? Just remember, we have to do the same thing on both sides. That's why I go through and actually write out this step. So we have exponential base 2 and a logarithm base 2. And so if these two guys have to be the same, the 2 has to be the base on both sides. Okay, so now an exponential and a log are essentially going to cancel out, and we'll have x times x plus 2 is equal to 2 cubed. And again, moral of the story, when we see something we can type in a calculator, we should probably go ahead and do that. So we saw that a couple of videos ago when we had like log of 3, should probably type it in a calculator. If we see a number like 2 cubed, should probably type it in a calculator or just figure out what number it is. 2 cubed is 8. And then now this looks like a quadratic equation, so we just have to solve. So we're going to distribute the x. That'll look like x squared plus 2x equals 8. And then we move everything to one side. So subtract 8 from both sides. X squared plus 2x minus 8 is equal to 0. And then I think I can factor it as x plus 4x minus 2. Let's skip one step and say either x is 2 or x is minus 4. So we have two answers, but if you stare at the two answers, this one isn't actually going to make sense because we can't take log of a negative number. So I'm just going to cross it out right away. You should probably check for yourself. If you plug in 2 into the left-hand side, you actually get 3. So x equals 2 should check out. I think you should double check on your own.